My name is Julie Ralph. I'm a software engineer at Google. I work in the Seattle office, and I am the tech lead and author of Protractor. And so usually when I'm up here, I've been talking about end-to-end testing, but there was just a great talk about the style guide for end-to-end testing that we're going to be putting up on the website soon. And today I'm actually going to talk mostly about unit testing strategies, and specifically for Angular 2. So, before we get started, there's a couple principles that we're going to use to try to guide how we write tests for Angular 2 and how we write tests in general. Use the smallest test type possible. We already went over this in the style guide, but the general idea is if we can test something with a unit test, we should go ahead and use a unit test because it'll run faster and it'll probably run more often and we'll be able to get feedback faster. So for all of our components and services, we'll want to write unit tests. Tests are documentation. Tests are for discovering if you're confident about your app, but they're also for documentation. So we want to write readable tests that are little mini examples of how to actually use our code. And we want to make sure that we only test public interfaces when possible. This means that our tests won't break when we change private implementation details, and it also makes sure that they're good little examples of how your code is actually used. Don't mock unless there's a reason to. This was also covered in the style guide, but it's also true for unit tests. Some people, when they're writing a unit test, feel like they can only use code from that one file in their test, and they have to mock out absolutely everything else. And there's really no need to do that if your dependencies are quick and don't cause any side effects that you're worried about. So don't mock out unless you need to. We'll show you how to mock out later in this talk, but don't always have to. And finally, test all the time, and make sure that your tests fail, and make sure that they're actually running. Make sure that when they fail, they give you a good message that you can go in and understand, and that you can debug them properly. All right, so with those principles in mind, let's go on to the actual setup and tools that we're going to be using for these unit tests. So in this talk, I'll assume that you're writing your application in TypeScript, but you could easily translate to using just plain old JavaScript. And we're going to be using Karma for our test runner. Karma was developed by the Angular team and is really great for running tests, unit tests quickly using a real browser, being able to run them whenever you save, and having really nice configuration options. It's used for testing all of the Angular 1 tests, and it's used for the Angular 2 own repository at the moment. So we'll use Karma. And for our test framework, I'm going to be showing tests in Jasmine. At the moment, the Angular 2 testing library only works with Jasmine, but we are working to make this more general and more generic so that you can use other frameworks like Mocha if that's what you prefer. But it should look fairly similar to all of the behavior-driven testing frameworks. I've made a little repository that's available on GitHub that is a seed repo for an Angular 2 app that shows unit testing. A lot of the seed repos out there don't yet show how to unit test, so I'm excited about this one, and I hope that you'll go take a look at it, fork it, play around with it, clone it, and try setting up your own tests based on that. It's really simple. It's designed to be the minimum setup that you would need. So the file contents are just a package.json file. We're using npm to grab Angular, like you've seen in talks earlier today, and all the other tools that we'll be using. We have a configuration file for Karma and a configuration file for our TypeScript compiler. And then there's this Karma test shim where all of our gross little changes that we have to do go. Right now, this is specifically for using the System.js loader, but could be easily adapted if you're using something else like Webpack. And it also has a couple of little helpers for things that we need to set up for Angular 2 in general. And then finally, we have a source folder with all of our TypeScript files in there. There's also a couple of npm scripts in the package.json file, which let us clean the repository, build, watch, which is essentially just building whenever a file changes, serve a development server, and finally run our tests. And these are all really simple little command line. You can go and take a look at them. Most of them are just a couple of characters. Our general strategy is to be having the TypeScript compiler running in one process and watching our TypeScript files and continuously outputting JavaScript whenever we change one. Karma's then just going to go and directly watch that JavaScript output and always be running and run pass-fail whenever it sees a JavaScript file change. So essentially what we've got is a setup where when you save your file, you'll get your test output right away. And this means that Karma doesn't have to know anything about TypeScript or how to compile TypeScript. And that means that you're not duplicating parts of your build process inside your test process. Okay, so let's look at some actual tests. There's going to be a lot of code for the rest of this presentation. The first thing that we need to do is have some sanity tests to make sure that our framework's actually working and we know what a test looks like. Take a look at that. What's wrong? 1 plus 1 does not equal 3. All of the tests that I'm showing today are going to be what I like to call almost passing tests. And I always write tests like this when I first write them, because I want to know that it's actually running, it's getting to the assertion steps that I'm looking for, and that when the test fails, the output looks sane. So try to find the problem in all of the tests in this presentation. And what this is showing is that we've got the describe and it functions from Jasmine that we're using to organize and write our test cases. And we're performing assertions with the expect function and matchers on it. We've also used the exit function here, which skips a test. So even though this test would fail, the output that we'll get is we only have 1 failure with a reasonable message, that 2 is expected to equal 3, and also that we've skipped a test. So we're using TypeScript. Let's add a class to test. This is a calculator class that essentially does the same thing as the last test, and we just go ahead and actually instantiate it right within the test and use it. But we're going to be testing Angular applications, and in Angular applications, you have services and components that might have a whole lot of dependencies and be difficult to instantiate. And Angular has this great dependency injection system, so we just want to use that dependency injection directly. And we can do that with the Angular 2 testing library. This library is available when you download the NPM package from Angular 2 testing. So we're just going to go ahead and use that. We'll import those Jasmine functions, it, describe, and expect, because Angular needs to wrap around those to work properly. And we'll also import a function called inject. And the way that we're going to use this is within our test. Instead of having a plain old function that's the actual test function, we'll wrap it all in a call to inject. And the first parameter here is a list of the tokens that we want the test injector to give us. And this is similar to what you would use in the constructor of anything that's using Angular 2 dependency injection. So here I'm getting this app ID token, which is a little thing in Angular 2 that lets you change the prefix that it gives to component CSS that you don't want to leak. Anyway, this needs to be set up for any Angular application. So the test injector has automatically created it for us. And we get an instance of it. We can perform assertions on that. Before we do any more tests, it would be helpful to have an actual application that we're testing. So I've created this very simple little pin machine here. It has a little border. It's got a little component inside. It has a status box and asks you to enter a pin and perform some verification on it. So here we'll see the login failure. The correct pin is the year number. So we enter that, and it tells us welcome. That's super simple little application. It has 2 services, the user service, which controls that input and the message, the login service, which gives us that processing and then returning a component. And it has 2 components, the greeting component, which is everything inside the border, and then that little border wrapper. Let's take a closer look at one of these services. The user service has a pin property. It has a method which statically validates whether the pin is valid between 0 and 10,000, 4 digits or not. And then it has this get greeting function, which uses a login service. And this is an asynchronous function that asks if login is correct using the pin. And if so, welcome message. If not, login failure. The login service is even simpler. It just has one asynchronous method which returns a promise that resolves to either true or false based on the input pin. And this is a slow login system, so this is going to use a timeout of a second before it actually returns the right thing. So back to testing. We need to set up the test injector and tell it that these are the services that we're going to be using. We use the before each providers function, which is similar to before each functions that you'd seen in Jasmine or Mocha. It runs before every it block, and you can nest them to make sure that you're loading exactly what you need for the test. And we pass it a list of providers for exactly what we need. So in this case, we need the login service and the user service. And this list of providers looks really similar to what you'd be using to bootstrap your Angular 2 application. Then, inside of our test, we can grab it from the list of things that we're injecting. We grab a user service. We can change its pin directly and run expectations. In this case, we're running the isValidPin function to test that that works properly. So, simple tests. But there was another method on the user service, which was that getGreeting. And this was an asynchronous method that returned a promise. So we need a slightly different strategy for dealing with these asynchronous things that we get from services. Instead of inject, we're going to use the inject async function. And the reason that there's two different functions that the testing library exports here is so that we can try to make sure that we don't make silly mistakes and use the wrong one. So everything that runs synchronously has to be inject. Everything that runs asynchronously has to use inject async. Inside the test, we'll return a promise for whenever we're done. So we'll use the user services getGreeting. We'll add a callback to that that actually performs our expectations. And then we'll return that whole promise. And inject async will complain at us if we don't actually return a promise. And conversely, inject will complain if we return a promise and said, hey, you probably wanted to use async. We've also added one final parameter to the test, which is a timeout. And this is optional and has a default value. But here we want to make sure that we give it at least 3 seconds, which should be plenty of time for that 1 second login to occur. OK, so these tests work, but they actually take a second for each test because it's using the real login service, which is pretty annoying if you have thousands of tests or something takes more than a second. And there might be other side effects that the login service creates that we don't want to deal with. So we want to be able to mock out services in our tests. And we can do this by creating a little service inside the file, a mock login service, which just extends from our usual login service. And this returns immediately. It returns a promise, so it's still asynchronous, but it's not spending a whole second doing the operation. And we're always going to resolve to true. We're not even going to check the pin here. And then here's what the test will look like. In the before each providers, we'll provide login service using mock login service. And then our test looks essentially exactly the same. But we don't have to extend the timeout because it'll run quite quickly. Again, it's still asynchronous. It's still returning a promise, but it's not taking a whole second. There's another option that we can use alternately to make these tests run faster, which is to use the fake async service from Angular 2 testing. And what fake async is going to do is wrap our entire test, and it uses a zone to listen when set timeouts or callbacks or promises are registered and capture all those. And then instead of actually running them asynchronously, whenever we use this tick function, it'll simulate moving time forwards and call those functions immediately. So here's what this actually looks like. We've wrapped everything in a call to fake async. We store the value for the greeting that we will get when we call back from the promise. We use tick to move time ahead by 200 milliseconds. And then, synchronously, we expect that the greeting is equal to whatever we want. So this is another option that you can use to deal with asynchronous tests and make them run faster and have fine control over exactly when things fire. So, as a quick summary of what we've done so far, we've looked at the Angular 2 testing library. We've seen that you'll import wrappers for Jasmine it describe functions from there. We've used before each providers to set up our test injector and the ingest function to get at values that we've set up, remembering that we need to return promises from injecting async. And we looked at fake async and tick to simulate async actions. So now let's go ahead and test some components. The two components that we had were the greeting component and the border. So let's look at the greeting component first. This uses an input number and a button and then has one output of the greeting being bound to a header element. And it uses a ng model from the form directives to manage the pin entry. The class is pretty simple. It just has the greeting property, which changes when you use the enter method. And we also are going to go ahead and store a promise that's pending whenever we are waiting for the login service. So for testing components, the Angular testing library provides this test component builder, which is set up in the test injector. And we just grab it using our inject async function. The test component builder always returns asynchronously. So always use inject async when you're working with it. We ask the test component builder to create a greeting component for us, and it returns a fixture for dealing with this component that it's created. The fixture lets you detect changes from the component, it lets you destroy the component, and it also has this debug element property, which lets us get it a lot more information about what Angular knows about the component that it's created. Primarily, we can get at the actual native HTML element with the native element property. And then, this is HTML, so we can check what its text is supposed to be. We can use query selectors on it, and also assert that those have text. In this example, I'm using a couple of matchers that we've created for Jasmine to contain text and to have text. Those are just simple little Jasmine matchers that look at the text content of the HTML element. We can also change things on the component from our test. So here we use the test component builder to get the fixture for us. We use the component instance property on the debug element, and that's actually an instance of our greeting component. So we can go in and directly change the greeting property of it to whatever we want. Let's change it to foobar. Run change detection to make sure that the template updates, and assert that our HTML element has the text that we expected. So we looked at the root test component, which is this text fixture that's returned from the test component builder, which has the debug element on it, lets us run change detection, and lets us destroy elements. And also lets us get at the debug element, which is the component instance, native elements, and also contains a lot of other information about what Angular has been using to compile and inspect this element. Like you can get hold of the element reference, get hold of children of the element, and query it by children that match a certain directive, for example. There's a couple other things that the test component builder can do. We can override values from the component to make it easier to test. Here we're going to override the template of the greeting component and get rid of the whole button and input and just make it a simple span that's bound to one greeting value. We override, we go ahead and create the component, and then we can verify that the text is exactly what we expect without any cruft around it. Another thing you might want to do when testing components is fire events. Because we can get a hold of the native element, we can go ahead and just use plain old JavaScript to fire a click event. So in this case, we're firing a click event on that enter button, and then we want to verify that our status has changed. If you remember, the status uses the login service, so this is going to be an asynchronous action. Fortunately, we kept a promise on our component instance, which is this pending value, so we can register a callback there that once the login is all done, we can go in, run change detection on the fixture again, and then verify the outcome that we expect. And we have to remember that we need to return this inner promise so that our inject async function knows that there was more testing to be done. And this is one of the reasons that I really like to have these almost passing tests, because here, this will fail, because the status should not be welcome with an X at the end, it should just be welcome. And we can see that fail and know that we're actually running all of our test code, even though it's asynchronous. We could also use our fake async friend from before to manage this asynchronous firing of events after clicking enter. So we would wrap everything in fake async. We would ask the test component builder to create the test fixture for us And then we would run a tick to make sure that all of those events fire, simulated synchronously. Then we run the click event, again, run another tick, and then we can synchronously detect our changes. So the test component builder lets us override the template, which we saw. There's also a bunch of different options that let you fine-tune exactly what you want to override. So if you need to override other aspects from the view metadata, you can do that. You can override child directives or components if you have a particularly complex component, then you don't want to test subparts of it. You can override providers and view providers to have fine-grained control of dependency injection. And then finally, you'll call create an async to actually get at your test fixture. So I have time to quickly run by one more set of component tests for a slightly different example. This was the final component in our test application, which is this border. And this uses ng content to basically just surround it with a couple of simple divs. It uses a title input and places that at the top and bottom. So there's not much to test in this component, but what we might want to do is test that we can use it properly. And we can do this by creating an on-the-fly component within our test, which uses the border component. So right within our test file, we'll go ahead and make a little component. And we won't even give it a template because we're just going to override that in each individual test case to be exactly what we want. But we will mention that it relies on the border component directive. And then within our tests, we'll use the test component builder to override its template for that specific test. So in this first case, let's override it and make sure that entering content inside of the fancy border works as properly. So we expect that that content text element gets in. And we could write a different test where we override it with a different template that tries the title input and makes sure that that gets output properly. All right, so that's all I have time to talk about today. Please do go check out that test seed application. And we are actively working on the testing library, so please let me know if you have any feedback or things that you'd like to see there. And I believe my AMA is right after this, along with Carmen and Andres, so come say hi to us. Thank you.